So there are 4 CAN frames: data frame, remote frame, error frame and overload frame. In this presentation we are going to focus much on the error frame. There are 2 types of error frame: active error frame and passive error frame. How the active error frame and passive error frames are differentiated? The active error frame sends out 12 consecutive zeros followed by 8 consecutive ones, which is active error frame. What do you mean by passive error frame? 12 consecutive ones followed by again 8 consecutive ones. So there are 20 consecutive ones means it is passive error frame, and 12 consecutive zeros and 8 consecutive 1 means it is active error frame. Okay, so the nodes will transmit the active error frame as well as the passive error frame, which we will be discussing in detail one by one in this presentation. So there are several possibilities of errors in a CAN bus while communicating between dashboard to the ABS, dashboard to the braking system, dashboard to the engine system, etc. How these errors are detected and how these nodes which are keep on sending the errors will be disconnected from the CAN bus. These are all one of the special features which has to be understood from the CAN bus. Quickly we'll refresh about all these things. Okay, so several different types of error conditions are defined in the CAN protocol. So if there are faulty nodes, and what action is taken on faulty nodes is called as fault confinement. So based on the fault data, the CAN nodes can also be totally disconnected from the network automatically. That is what we are going to see now. And the fault confinement prevents faulty nodes from the continuously transmitting and bogging down the network. So when the node is keep on transmitting the error messages, the fault confinement will stop that particular node from the particular network. We will see one by one, starting from CRC error. After the arbitration is over, one node will catch the bus. The node with highest priority message ID will catch the bus, and the control field will notify how many data bytes are there in the data field, and the data has been transmitted, and all the nodes will receive and all the nodes will check for the CRC field. When the CRC field is identified an error by a particular node, if any node detects an error in the CRC field, that will transmit an error message. That is what we are going to see here. All nodes receive message, calculate CRC and verify against the CRC received. If the CRCs do not match, a CRC error occurs and an error frame is generated. So the transmitting node sees an error occur and retransmits the original message. The second error is an acknowledgement error. So normally how do the received node acknowledges? After the CRC field, the transmitter will leave the bus in the receive mode. Any node that receives this message has to make this particular acknowledgement bit as dominant. The transmitter will understand from the dominant bit in the acknowledgement field saying that at least one node have received the data. If a dominant bit occurs, at least one node received the message correctly. If not, an acknowledgement error is occurred. An error frame is generated and the message will be repeated. There is another error called form error. If there is a dominant bit in the CRC delimiter, if there is a dominant bit in the acknowledgement delimiter, or if there is a dominant bit in the end of frame, form error is identified and an error frame is generated. That is the one you need to understand, which is called as form error. Then there is a stuff error. As we know very well, 7 consecutive ones is end of frame. So more than 5 consecutive ones or more than 5 consecutive zeros are not allowed. The 6th bit, if 5 consecutive ones, 6th bit should be stuffed with logic 0. If there are 5 consecutive zeros, the 6th bit will be stuffed with logic 1, which is called as bit stuffing. If there are 6 consecutive ones in the data field or control field or in the CRC field, then that justifies there is an error. Which error? Stuff error. So an error frame will get generated. That is what mentioned here. Stuff error. If 6 consecutive bits with the same polarity are detected between the start of frame and the CRC delimiter, the bit stuffing rule has been violated. An error frame is sent and the message will then be repeated. Then there is a bit error. What do you mean by bit error? This is very interesting. Every node, when it transmits a dominant bit, it has to check the dominant bit, which is happening in the arbitration field. Once the arbitration is over, only one node will have the bus. So that node will transmit every bit and then it will look back the same bit in the same transmitter itself, because every node what it transmits, it has a capability to receive that particular bit. If there is any mismatch in the received bit, then it generates a bit error. Bit error occurs when the transmitter monitors a signal on the bus and it is opposite of what it sent. During the arbitration, some nodes which will send the recessive bit will receive back the dominant bit, so that is not a bit error. That's why from the control field bit error is happening. And in the acknowledgement slot, the transmitter will send the recessive bit. The node which receives this data will send back the dominant bit. So there are two exceptions for the bit error. During arbitration, the transmitted bit will not be equal to the received bit, and during the acknowledgement, transmitted bit will not be equal to the received bit. Hence, except the arbitration field as well as the acknowledgement field, wherever the control field, data field, CRC field and in end of frame, bit error will be, there is a possibilities of bit error, and whenever there is an error in the transmission and reception, then error frame will get generated. So recovery from bus off. What do you mean by bus off? This is very interesting. So there is error active and there is error passive and there is bus off states, which is very interesting. So when the microcontroller is reset or when the CAN bus is reset, it will be in the error active state. What do you mean by error active states? So this is nothing but REC, TEC. What do you mean by REC? Error counter. Receive error counter and transmit error counter. Okay. Whenever error frame is generated, then the counter will increment. Okay. So that is receive error counter. When the receive error counter is less than 127 and the transmit error counter is less than 127, then we can say error is active. When the receive error counter is greater than 127 or the transmit error is greater than 127, that is, if there are 127 error messages from a particular node, then it becomes the error passive. So if the transmit error count is greater than 255, whenever a particular node keep on transmitting the error messages, and if it exceeds 255, that node will be disconnected from the CAN bus virtually. It is physically connected, but it will never given the privilege to transmit any CAN data. Why? Because it is keep on sending the error message, disturbing the bandwidth of the CAN bus. Hence, when the transmit error count is greater than 255, that node will disconnect itself from the CAN bus. This is one of the special feature in the CAN bus, which is very interesting. That is what being discussed, right? So active error, error active and error passive and bus off state is being discussed here very clearly through this diagram. So two methods of to recover: change to configuration mode. So how to recover from the bus off state to error active? Because bus off means it is totally isolated. So how to recover from the bus off state to the error active state means change to the configuration mode. Either we have to change to the configuration mode or detects 128 occurrence of 11 consecutive recessive bits. Okay, that is long bus idle or 128 valid messages or a combination of both will make the bus off condition to the error active condition as discussed. So this is called the fault confinement. Every node will have an error counters. There is a transmit error counter and receive error counter. At initial stage, transmit error counter is 0 and receive error counter is 0. So the CAN module will keep on transmitting the CAN data through the CAN bus in the bus topology. When either error counts exceeds 95, it causes a warning interrupt. When the transmit error count is greater than 127, that means this node is transmitting the error message and it is greater than 127 means it will become error passive. The node will become error passive node, and the other nodes which is not yet transmitting any error means that will be in error active state. So here out of 3 nodes, 2 nodes are in error active and 1 node become error passive. Passive why? Because it transmits more than 127 error messages. So all the 3 states, error active state, because the transmit error count, receive current error count all are 0. If the receive error count is greater than 27, so this node has become error passive, and this node is totally disconnected from the CAN bus. Why? Because the transmitted error count is greater than 255. Okay, transmit error counter itself will disconnect the node from the CAN bus. These are all the error states, and this is how error handling or fault handling is happening in the CAN bus. Thank you.